We're in Unit 7, the mole. So far to this point, we've been talking about how a mole is a specific quantity. We use it to measure the amount of a substance because usually the number of the amount is too big, and so a mole makes it nice and manageable. So we talked about how 1 mole represents a specific number of atoms or molecules or whatever type of particle we're talking about. And we also know that 1 mole of a compound has a specific mass, and we can use the chemical formula and the periodic table to figure that out. And we also found that if we're talking about a gas and certain conditions are met, then 1 mole occupies a very specific volume. And all of these are just relating to the amount of the substance. Now we're transitioning into how can we apply these concepts that we figured out? And one of the first things that we do is talk about percent composition. Percent composition tells us about the makeup of a molecule. Percent composition tells us how much mass each element contributes, and we can calculate the percent mass from the chemical formula. From the chemical formula, we can calculate the molar mass and the total mass of each element in the compound. So the first thing we'll look at is water. Water is composed of 2 hydrogen atoms and 1 oxygen atom. So if you just look at the formula, H2O, you can see that each molecule has twice as many hydrogen atoms as they have oxygens. But this can be misleading. Before we do that, let's look at the mass of water. So let's make our table. So H2O, molar mass, quantity, and total. So there are 2 elements involved in water, hydrogen and oxygen. The molar mass of hydrogen comes from the periodic table, 1.01, and oxygen rounds to 16.0, also from the periodic table. The next column, quantity, comes from the chemical formula, and we see that there are 2 hydrogens. We see that there's only 1 oxygen, and we're good to move on. Now remember what we're doing here. We're basically looking 1 row at a time, and we're multiplying these 2 numbers together to get a total. So hydrogen has a molar mass of 1.01, and there's 2 of them, and so the total mass of hydrogen, let's leave it as a number, 2.02. And the total mass of the oxygen, 16.0. And when we add these 2 together, that's where we get the molar mass of the compound. And for the case of water, it's 18.0 grams per mole. This 2 on the end of it got rounded off due to significant figures. So just the formula could be a little bit misleading. It looks like there's a lot more hydrogen there, and by the number of atoms, yes, that's true. But if you look at it by mass, it might be different. Most of the mass of the water, if you look at these totals, is oxygen. So the molar mass of the water itself is 18 grams per mole. The molar mass of the oxygen, or the total mass of the oxygen, 16.0 grams per mole. And the molar mass of the hydrogen atoms, 2.02 grams per mole. Should probably stick in the word total right here. total mass of hydrogen atoms. So percent composition helps us to look at this a little bit differently. And there's a formula, and I say formula, but it's really just what numbers to use to find a percentage. So let's go ahead and write this down. Percent composition. And for a specific element, it's the total mass of the element divided by the mass of the compound. So let's say the molar mass of compound. And this is going to give us a decimal. We're talking about percent composition, so we have to multiply it by 100 to make it a percentage. Because we're looking at part of a whole, this gives us a decimal, this gives us the percentage. So let's look at how this works for water. So if you look at the percent hydrogen, our formula says the total mass of the element, and that is this box right here. 2.02, and you can put in the units if you want. It's grams per mole. And divided by the molar mass of the compound, 18.0, and that's also grams per mole. I'm not going to write it in here because what we have is grams per mole over grams per mole, and it's going to cancel out. This would give us a decimal. It'd be about 1/9, and that'd be 0.11 and so on. Multiplying it by 100 makes a percentage, and if you put this in your calculator, you'll find that hydrogen only accounts for 11.2% of water by mass. Remember, this is by mass, not by number of atoms. We can do the same thing for the oxygen. The percent oxygen equals the total mass of oxygen, 16.0, divided by the total mass of the compound, or the molar mass, and times 100 equals 88.8%. So this is one oxygen atom accounting for 88% of the mass of water. This is two hydrogen atoms accounting for only 11.2% of the mass. So let's look at a couple others. We've got room for maybe one more. I'm going to do two more, and I'm going to erase this one. Hopefully you have room for one more. If you have room for two, that's great. If not, you might pause this and find a separate sheet of paper. So the next one I'm going to look at is a compound that we've talked about already in this unit, CH4. So by our naming system, it's carbon tetrahydride. Most of the world just calls it methane. This is your main component of natural gas. So CH4, molar mass, quantity, and total. So I'm going to make my table. Table is actually very helpful for percent composition. Outside of percent composition, once you know how to do molar mass, I would say stop doing the table. But for percent composition, it gives us our numbers. It's really helpful. Carbon and hydrogen are the elements involved. Molar masses from the periodic table. Carbon 12.0. Hydrogen rounds to 1.01. Quantity comes from the formula. 1 carbon, 4 hydrogens. Totals, we have 12 grams per mole of this is carbon and 4.04 grams per mole of this is hydrogen. So let's add these together. According to our significant figures, rounding rules, we're at 3 significant figures, and so this 0.04 rounds off. So our percent by mass of carbon, its total mass was 12.0, and the molar mass of the compound is 16.0. And this is times 100 to make it a percentage. Comes out to be 75.0%. For the hydrogen, 4.04 divided by 16.0 times 100 to make it a percentage, and we come out to 25.3%. And this is where you're probably looking at it and you total this up and it comes to 100.3%, and you're probably drawing a big question mark right here. In chemistry, if percentages don't add up exactly, it's going to be fine. 100.3 is okay. And the reason behind this is it's the rounding. So let me work back a little bit and I'll show you what actually happened here to make it this. It was our own fault. 100.3 is not a huge deal. It's statistically not an issue. So let me erase this and go back to the point where the issue started. Here. So let me put in this 4 here. 0.04. And so we start updating our numbers. Carbon 16.04 this time. And this one ends up as 74.8%. Last time it was 75. Now it's 74.8. For the hydrogens, 4.04 divided by 16.04. And we come out with 25.2%. And if we were to total all this up, 0, 0, there's 100%, and that works out. It was all rounding, so nothing really to worry about there. Just know that sometimes it's not going to be exact. The way our class works, I factor in a certain amount of error for every answer. So if you had rounded it here and told me it was 75.0%, it would accept it. If you didn't round here and you told me it was 74.8, it would also accept it. And so it's somewhat flexible with the way it works with the answers. So let's take a look at one more. This time we'll talk about SiCl4. Same table, molar mass, quantity, total. There are 2 elements involved here. Silicone's molar mass 21.8, chlorine 35.5. 1 silicone, 4 chlorines, and then we total it up. Let's see, we got 71, 142. And so when we add these up, 170, and that 0.1 rounds off. So we'll say 170 grams per mole. So now let's look at our percentages. So the percent silicone in this compound, the total mass of the element, 28.1, and the total mass of the compound, 170. Times 100 makes it a percentage, and it comes out to 16.5% by mass. The percentage of this compound that is chlorine, total mass of the element is 142, total mass of the compound 170. Times 100 makes it a percentage, and this one comes out to 83.5%. Now this one, if you were going to add them together, and it comes out to exactly 100. And sometimes it will, sometimes it won't. Even here, we rounded it here, but this 0.1 was so small compared to the fact that it was 170 that it didn't matter. So this is percent composition. It's something we'll be working with in class.